My dear students, this is Mr. Rizq Allah, Math teacher. I hope you enjoyed your holiday and had fun. As you know, we were supposed to take some lessons in the rest of March and April, but it didn't happen because of coronavirus. So please stay healthy and safe and take care, because we care a lot about you. School is very important, and so is your health. Algebra. Multiplicative inverse of a matrix A, which denoted by A negative 1. For any square matrix A, which equals matrix AB and CD, we can find the value of its determinant, which is denoted by delta, and it must be different than 0. We also know that matrix A multiplied by multiplicative inverse A negative 1 from the right hand side or left hand side, it will be equal I, which is the identity matrix of the multiplication. To get the multiplicative inverse of matrix A, which is A negative 1, it will be equals 1 over delta multiplied by the same matrix A after change the elements of the main diagonal and change the signs of the other diagonal. So A negative 1, it will be equals 1 over delta multiplied by the matrix D negative B and negative C A. Examples. Number 1, if A is a matrix 3, 2 and 5, 4. Number I, prove that there is multiplicative inverse. Double I, find this multiplicative inverse, which is A negative 1. Solution. Since matrix A equals 3, 2 and 5, 4, therefore its determinant delta equal determinant of 3, 2 and 5, 4, which equals 3 times 4 minus 2 times 5, which equals 2 differ than 0. Therefore, the multiplicative inverse of this matrix is exists. Double I. To find this multiplicative inverse from the rule, which is multiplicative inverse A negative 1 equals 1 over delta multiplied by the matrix A after change the elements of the main diagonals and change the signs of the other diagonal. So A negative 1 equal 1 over delta multiplied by the matrix 4, negative 2 and negative 5, 3, which will be equals finally the matrix 2, negative 1 and negative 5 over 2, 3 over 2. Example 2. Find the value of x which makes the matrix P equals x3 and 12x has a multiplicative inverse. As we know, any matrix has multiplicative inverse if its determinant differ than 0. So, the determinant of the matrix B must be differ than 0. So, delta equal determinant x3 and 12x not equal 0. Therefore, x squared minus 36 not equal 0. It means x not equals positive or negative 6. Example 3. If matrix A equals x negative xy and 0 y, where xy not equal 0. Prove that a negative 1 equal 1 over x, 1 and 0, 1 over y. Solution. Determinant of matrix A delta equals determinant of x negative xy and 0 y. Therefore, delta equal xy minus negative xy times 0, which will be xy. Not equal 0 from the given. Since a negative 1 equal 1 over delta multiplied by the matrix after change the elements of the main diagonal and change the signs of the other diagonals, therefore a negative 1 equal 1 over xy multiplied by the matrix y, xy and 0 x, which will be get 1 over x, 1 and 0, 1 over y. That's required to prove. Example 4. If matrix A equals 2, negative 2 and negative 1, 3, and AB equals the matrix 4, negative 2 and 0, negative 7, find the matrix B. Solution. Since AB equals the matrix 4, negative 2 and 0, negative 7, multiply both sides by multiplicative inverse of the matrix A. Therefore, A negative 1 times AB equal A negative 1 multiplied by 4, negative 2 and 0, negative 7. Therefore, the matrix B equals A negative 1 multiplied by 4, negative 2 and 0, negative 7. That's equation number 1. The determinant of the matrix A, which is determinant of 2, negative 2, 1 and 1, 3. Therefore, it's equal 2 times 3 minus negative 2 times 1 equals 8, differs than 0. Therefore, the multiplicative inverse of the matrix A equals 1 over 8 multiplied by the matrix 3, 2 and 1, 2, which will be the matrix 3 over 8, 2 over 8 and 1 over 8, 2 over 8. That's equation number 2. From the two equations 1 and 2, the matrix B will be finally equals 3 halves, 1 and a half and 3 halves. That's QED. Note number 1, A negative 1 all negative 1 equal A. Number 2, AB all negative 1 equal B negative 1 A negative 1. It means in the reverse order. Number 3, ABC all negative 1 equals C negative 1, B negative 1, A negative 1, also in reverse order. Try to solve. Number 1, if matrix A equals 3, 0 and 2, 1, find number I, A negative 1, double I, A negative 1, all negative 1. Question number 2, If A is a matrix 3, 1, and 4, 2, and B is another matrix 2, 1, and 3, 1, prove that AB all negative 1 equals B negative 1, A negative 1.